So, welcome to lesson 6 of your ecology unit. These remote lessons on YouTube, looking at cycling materials. So, as you'll see on the page 2 of your ecology part 2 booklet, lesson 6 starts with some knowledge check questions. So, if you have a little look at those questions, pause the video at this point, review any notes that you've got from lesson 1 to 5 and see how many of these questions you can answer, and then unpause the video and we will carry on looking through the answers in a moment. So pause the video and have a go, please. Right, you should have unpaused the video, so if we go through the answers nice and efficiently. So state the units of biomass. Biomass is measured in grams per meter squared. Name the key source of energy for life on Earth, and that is the sun. Define a habitat. If you remember from previous lessons, that is the area where a species or a population, where a population of an animal, of an organism, lives. Name 2 groups of decomposers. Bacteria and fungi, 2 organisms that go about breaking down other organisms and extracting nutrients from them. Name the reactants of aerobic respiration. Aerobic means with oxygen. So the reactants are the things that react together to allow respiration to occur. So that is oxygen and glucose. What are 3 ways that biomass is lost along a food chain? So you can lose energy via heat loss, excretion, and respiration. Define an ecosystem. It is the interactions between living and non-living parts of an environment. Now, name the waste products of respiration. So these are the things that are made, produced, that aren't needed. So remember, respiration generates energy. It also generates carbon dioxide and water. Good. So those are your knowledge check answers. So once you've done those, you can then turn onto your next page and have a look at, on page 3, the first paragraph. I'm just faffing about on my pages, apologies, on cycling and interdependence. So if you have a look at the start of the paragraph, it will begin with many different materials constantly cycle through the abiotic and biotic parts of an ecosystem. Now, if you remember from previous lesson, abiotic are the non-living parts and factors that affect ecosystems, and biotic are living. Substances like carbon dioxide and water are recycled so that there is always enough to provide the building blocks for future organisms. Building blocks. Now, we've talked about these in previous lessons, but we're talking about monomers of biological molecules. So biological molecules, we're talking about things like glucose, we're talking about things like proteins. So if you think about this example, building blocks, building implies growth. Now, what building block, what biological molecule do we need for growth? We need proteins. We need proteins, and proteins are made out of glucose and nitrates combining together to form amino acids. So, substances like carbon dioxide and water are recycled, so there's always enough to provide the building blocks for future organisms. Now, how is that glucose produced? How is that glucose produced in relation to carbon dioxide and water? What's the process which carbon dioxide and water are needed for that's essential for all life? That process, if you remember, is photosynthesis. So that plants can generate energy, and that energy can transfer up food chains and food webs throughout organisms and entire ecosystem. So so it can provide the building blocks for future organisms once older or diseased ones die. So these nutrients and useful molecules are recycled. So the nutrients and useful molecules that make up old organisms that have died off are recycled. Organisms, particularly microorganisms, play key roles in recycling, including the return of carbon dioxide to the atmosphere and mineral ions to the soil. Now, if you remember, organisms, particularly microorganisms that play an important role in recycling, those are your decomposers, which, as we said earlier, made up a lot from bacteria and fungi. Now, interdependence describes the relationship between species, i.e. different species working together to coexist. Intradependence is organisms within the same species relying on each other. For example, when lionesses work together to hunt for food, this is for the whole pride. Now, interdependence, organisms are working together, they are relying on each other. So they rely on each other for things that they need for survival. Now, decomposers and other organisms are a good example of interdependence, because other organisms depend on the decomposers to break down and take water and carbon dioxide and mineral ions out of dead and dying organisms and put them back into the environment so that they can be used. And if you've got that other example, intra, remember intra is the same, inter is different. Good. Right, now let's have a little look at the water cycle. So if you see in the paragraph on page 3, under the water cycle, I've got some information to go through. So, the water cycle describes movement of water in an ecosystem or an environment. Where does it go? Where does it come from? Where does it go? Now, if we go through this, the energy from the sun makes water evaporate from land, rivers, and the sea, as well as from plants during transpiration. It evaporates because it heats it up. Now, remember, transpiration is the movement of water within a plant from root to leaf. It's the movement of water within a plant. Now, as water warms, it rises up into the air. As the air temperature reduces, when the water increases in altitude, the altitude is just another way of describing height, the water condenses to form droplets. So when something condenses, it's turning back from a gas, vapor, to a liquid, which we see as clouds. Water then falls from the clouds as precipitation onto land to provide fresh water for plants and animals. Now, precipitation is what we know as rain. Water usually falls as rain, but can come down as hail or snow if the conditions are cold enough. Water then drains from the land into the rivers and eventually the sea before the process begins again. Now, water draining through the land, there's a word for that, and water draining into deep rocks and through the land and making its way into underground streams is called percolation. Now, water that you find underground, funnily enough, is called groundwater. And then water that you find that falls onto land is called surface water. Now, this is just a summary and a description of the movement of water through an ecosystem. So we're going to spend a bit more time looking at this in depth. So, to begin with, pause the video, have a look at your paper resources, PDF resources, and see if you can find and load up this YouTube video for me. Try and put the link in the comments below for you to be able to find easily as well. Watch the following clip, and on your student's notes page or just any other revision book you've got, make notes and draw a flow chart to show the steps involved in the water cycle and the carbon cycle. So you want 2 diagrams, okay? From this video, basically summarize the flow, the steps involved in the water cycle and the carbon cycle. Once you've done that, unpause the video, come back to this, and we will go through the rest of it in as much detail as we can on the next page. But that is your next task right now. Pause the video, find the link, have a go at producing those 2 flowcharts and diagrams describing the water cycle and the carbon cycle. Right. Should have done that, so you should be unpausing the video now, and we will be moving on. Now, if we move on, we can have a little look at the next steps, which is our diagram. So, got a nice little diagram that just helps us to summarize some of these steps. So, as we've said already, water is removed from lakes, rivers, streams by getting heated, and that heat turns the water into vapor, and that is through evaporation and out of a plant. That is via transpiration. We also, just thinking about plants and living organisms, remember you can lose water via respiration. It's a waste product of respiration as well. Then, once that water and vapor has reached into the atmosphere, it gets colder and it condenses to form clouds. The clouds are full of raindrops, which are heavier and then fall as precipitation. And then that water seeps onto the ground, runs across the ground as surface water, or runs underground as groundwater, and moves through the rocks by a process called percolation. So, describe each of these steps. So, evaporation. Why does water evaporate in an ecosystem? Clue is in the diagram. It's the sun. It heats the Earth's surface. And the water turns to vapor. And if you've got increased vapor, water vapor in the air, that means you end up with warmer, moist air. So if you have an increase in humidity, you have an increase in moisture, increase in water vapor in the air. Transpiration. And you could also say and respiration. Loss of water vapor directly from plants to the atmosphere. Condensation. What is condensation? So, as warm, moist air rises, gets higher in the atmosphere, which means the temperature gets colder, it cools. So, it then condenses back to droplets, and those droplets collect in clouds. Precipitation. What have we said precipitation is? Now, water droplets, as they form from condensation, are they light or heavy? They're heavy. So they fall as rain, snow, or hail, dependent on temperature. And then percolation. Percolation is water moving through what? It's water moving through gaps in soil and rocks. Right, good. So I've had a go at that. Now, what I'd like you to have a look at underneath that is some examples of some exam questions around this topic area. Now, I'd like you to pause the video and have a look at these exam questions and see if you can use what you've done in the video, what we've just talked about there, any other additional research that you can have a go at, to see if you can answer them. There are 3 questions. 6 mark, 4 mark, and 4 mark. Describe all materials in the living world are recycled to provide the building blocks for future organisms. Water is one example of a material that is recycled. A. Describe the main steps in the water cycle. 6 main steps. Identify and explain 2 ways in which animals return water to the environment, and explain the importance of the water cycle to living organisms. So remember, describe is saying what happens. So what is happening in the water cycle? 6 marks. Funnily enough, we've just described it up here. Identify and explain 2 ways in which animals return water to the environment. Now, identify is the what. What are the ways in which animals return water to the environment? Explain is the why. So you need to have 2 whats and 2 whys as to methods that animals use to return water to the environment. And then 3C, explain the importance of the water cycle to living organisms. So, explain is why. Why is it important? Why is the water cycle important to living organisms? So you need to be coming up with 4 points for that. So, pause the video, have a go at it. Once you've unpaused the video, we'll go through the answers together. Right. Hopefully you've had a go at that and you've unpaused the video. So, if we have a little look at some answers. So, if we start with, let's just make this a little easier for everyone to see. Fold this off in half. Right, if we have a little look at question A. Just Apologies for my handwriting. Right. Describe the main steps in the water cycle. What happens in the water cycle? Don't worry about necessarily order or anything like that, because you can start at different points in the water cycle, but you need to be saying, what are the different steps? 1 mark. Precipitation is water falling to the land, isn't it? Runoff. Water running into streams, rivers, lakes, oceans across the ground. Another mark. Percolation. Water trickling through gaps in soil and the rock to get to water sources. Another mark. Respiration. Water being released from animals, but also importantly plants during their lives. Also death and decay. That goes back into the environment. Transpiration. Water being released by plants. Evaporation. Water turning from liquid to water vapor as the sun heats it on the Earth's surface. And you could also say, and rises into the atmosphere. So it's worth just showing you've even got another one there. And then condensation, the water vapor turning back into a liquid as the moist air rises and the temperature gets colder. So precipitation, percolation, respiration, runoff, transpiration, evaporation, condensation. All key words you should be using to answer question A to explain the water cycle. Right, B. So you could use any two from these, because remember, you need to identify 2 of them and explain 2 of them. So, what are 2 ways in which animals return water to the environment? So it could be any 2 of these. Respiration, sweat, or urine. These are all valid answers. Now, respiration, the water is given out as a waste product. Sweat, water evaporates out of the sweat into the environment to cool an organism when it's too hot. You would have looked at that in homeostasis. Urine, water, excess water is filtered out of the blood by the kidneys into the urine, and then it's excreted. So you've got potential marks there. 1 mark, 1 mark, or 1 mark, 1 mark, 1 mark, 1 mark. The whats, the whys, 2 of each. And then finally, C, explain the importance of the water cycle to living organisms. So you've got different things you could choose from here. Why is the water cycle important? Because water is needed. It's a major constituent of all living cells. It's needed for the chemical reactions of life, photosynthesis, respiration. They take place in water, in solution. You need it to support plants' rigidity and their structure. Without it, plants wilt and they die. Water also transports minerals and nutrients through organisms. And then water also helps to dissipate waste materials from urea, excreting it. So any 4 from these would get you the marks for question C. So you've got some answers there. If needs be, go back, pause the video at each of those answers, make some notes, correct your work, and then from there we'll move on. Right, on to our next page. Just make this a bit neat for you all. Recycling elements. So we've talked about recycling water. Now we're talking about recycling elements within the environment. So let's break down this text into a little bit more depth. All living organisms are made from materials within their environment. Plants make complex compounds, carbohydrates, proteins, and fats from elements such as carbon, nitrogen, and hydrogen. If you remember, carbohydrates made out of glucose, for example, which we know is C6H12 O6. To make a carbohydrate, you need carbon, you need hydrogen, you need oxygen. Proteins are made out of amino acids, which, as we know, is made out of glucose and nitrates. Fats, we know, are made out of fatty acids and glycerol. Plants, and so we've gone through that sentence. Then the compounds then get passed along the food chain where they're broken down and returned to the environment as waste. So remember, these things can be excreted. Materials also return to the environment when organisms die and decay. So when something decays, a decomposer breaks it down. And these decomposers work best in warm, moist, oxygen-rich conditions. So decomposers can be microorganisms, also detritus feeders. It's another word for them. Organisms that digest dead material, and these are more active. So remember, our microorganisms we talked about that are good decomposers are bacteria and fungi. Now, a stable community relies on the balance between the materials taken and used from the environment and the materials returned. Stable communities reach equilibrium between the two. So remember, what examples have we talked about of stable communities? E.g., we've talked about woodlands and rainforests. So these achieve a balance of these materials either being taken in and used. So these are bioorganisms for life processes, e.g. things like photosynthesis and respiration. And then they achieve equilibrium. So remember, equilibrium, what's another word for it? A balance between the two. So they're either taken in and used and then returned to the environment in appropriate amounts so it doesn't decrease. Now, let's have a look at the paragraph below. So one of the other cycles of elements that you have to know about is to do with carbon. Because carbon is one of the most common elements found in molecular biology. Carbon is constantly being cycled as CO2 in the air into molecules such as glucose. We've already mentioned this, but what amount of carbon is used in glucose? Glucose molecules are C6H12O6. So you need 6 atoms of carbon for every glucose molecule. So it's via photosynthesis, and then this passes along food chains and back into the air again as a product of respiration. So remember, CO2 is a waste product of respiration. We breathe it out, we don't need it. The balance between respiration and photosynthesis has remained fairly constant in the most recent years of Earth's 4.5 billion year history. Because if you think respiration and photosynthesis, they're linked because they all involve CO2, water, oxygen, and glucose. Photosynthesis is using carbon dioxide and water to produce oxygen and glucose. Respiration is using oxygen and glucose to produce carbon dioxide and water. They are the almost back to front. The Earth has also the capability to store carbon within abiotic factors of the Earth. When the Earth stores carbon, we refer to that as carbon capture. Human activity, thus keeping it out of the atmosphere. So fossil fuels and limestone. If you remember, limestone is referred to as calcium carbonate, and a molecule of limestone is CaCO3, so it contains carbon. Fossil fuels, why are they so important? They trap lots of carbon, so when they're burnt, what's released? CO2 is released. So that's why burning fossil fuels releases carbon dioxide, because lots of carbon is trapped and captured inside of them. Human activities such as mining and digging for oil result in a rapid increase in carbon dioxide in the atmosphere due to the combustion of them. So remember, combustion is burning in oxygen, and that means carbon dioxide is then formed with carbon that's trapped within the fossil fuels. And this is having a significant effect on global warming. Because the reason being, if we think about it on a very practical level, CO2 traps long wavelength radiation reflected off the Earth's surface. And so it traps that radiation. Radiation energy, heat energy, which means temperatures increase. And it traps it in the covalent bonds. Of carbon dioxide. So it's trapped in the covalent bonds. Just a little bit of extra detail there for you. Now, you've had a little go at looking at this flow chart and kind of an idea in the video earlier, and we've just gone through those descriptions of the carbon cycle and what it does. So now, can you pause the video for me, please, and have a little look at this activity? Using your notes and using what you've gone through, try and add any detail that you can to the flowchart below that describes the carbon cycle. Once you've done that, we'll unpause the video and we'll go through it in detail and add what we can to it. Right, should have unpaused the video. So let's have a little look at it. So, detail of the things by which carbon can be moved around an ecosystem, moved around the environment. So first things first, how does carbon get from a tree using it during photosynthesis into an animal? Animals feed. It's transferred that way. How does carbon get from the tree into the ground? Death. How does it take carbon out of the air? Photosynthesis. How does a tree give carbon back into the air? Respiration. Then, again, the cow, the animal. How does the cow give carbon back into the atmosphere? Returns it via respiration. So it returns CO2 to the atmosphere, whereas photosynthesis removes CO2 from the atmosphere. Good. Now, we've got lots of CO2 in the atmosphere. How Does the carbon dioxide that's in a living organism get into the ground? Dies. Now, lots of carbon in organic compounds in dead organisms. How is that released? Decomposes. Decomposers respire and release and use carbon. Then, what's the other way? It can also be dug up as fossil fuels, so you can find carbon compounds carbon's in fossil fuels. And how do you get carbon out of the fossil fuels? Burn it in air. So you've got there a good little summary diagram that describes the carbon cycle. Right, now what I'd like you to do is, can you turn onto the next page and have a little look at some of the questions. So you'll see on the next page a little bit of text at the top where it says carbon dioxide can also be absorbed into the seas and oceans. Atmospheric CO2 dissolves into the water and is formed into carbonates which are insoluble. So remember, what's the carbonate that we've talked about? Calcium carbonate. Is an example of a rock formed in the ocean that contains carbon dioxide because it's CaCO3. So the reason why they stay in the ocean is because they don't dissolve, they're insoluble. These carbonates form sedimentary rocks and they lock the CO2 into them and prevent it from returning to the atmosphere. So this also is another method of carbon capture. Right. You'll now see on your page there's a selection of questions I'd like to have a go at. So I'd like you again to pause the video, use your notes, use any textbooks, use any other things that you feel you need support in terms of trying to answer these. Have a go at answering these questions. Explaining why plants require carbon dioxide from the atmosphere. Explain how animals acquire carbon to make organic molecules. Explain how fossil fuels reduce the CO2 levels in the atmosphere and increase them too. Explain how deforestation affects atmospheric CO2 levels and the impact of this on climate change. And describe the main processes in the carbon cycle and explain how two human activities are causing changes to the natural balance of the carbon cycle. Right, good. So, I'm going to give you time now to pause the video and to have a look at these questions. So, pause the video, have a look, and then we'll go through the answers. Right, should have unpaused the video. So, let's have a look at some answers. So, let's start with the question at the top. Explain why plants require carbon dioxide from the atmosphere. They need it for photosynthesis, and that photosynthesis generates glucose, which is needed for growth of the plant and also growth of other organisms. So that's your answer to that question. Explain how animals acquire carbon to make organic molecules by feeding. They can feed on plants and they can feed on animals, giving them carbon from both places. Explain how fossil fuels reduce the CO2 levels in the atmosphere and increase them too. So, fossil fuels are formed from decaying organic matter containing carbon. So, carbon is captured and locked into fossil fuels. It's then released. It's released through burning them. So that's how it's released, and that's how it contributes to the atmosphere, and how it's taken away is the carbon becomes captured and locked within the fossil fuels. So it's us as humans burning the fossil fuels and releasing it back into the atmosphere that's the problem. It's not the formation of the fossil fuels themselves. Then explain how deforestation affects atmospheric CO2 levels and the impact on this on climate change. So you can increase the CO2 levels, and if you've increased the CO2 levels, if you've got less plants available to absorb it via photosynthesis. So if you chop plants, trees down, you've got less plants available to absorb the CO2, so the CO2 level is going to increase. And as we've said earlier, if you increase carbon dioxide in the atmosphere, you're going to increase global warming as there's more CO2 to trap the long wavelength radiation that's reflected off the Earth's surface. So, less plants can absorb CO2 via photosynthesis. If you chop them down during deforestation, that increases carbon dioxide levels. If you increase carbon dioxide levels, you've then got an increase in global warming because there's more CO2 trapping long wavelength radiation that comes from the sun, the shortwave, bounces off the Earth's surface and then gets trapped in the atmosphere. Then, for the checkpoint question, pause the video and you'll see, look through your answer and see if you can get any of these 6 marks included within your answer. Burning, combustion, converting carbon in fuel into CO2. Photosynthesis, converting atmospheric CO2 into carbon compounds in plants. Respiration, decay and decomposition, converting carbon from food sources into CO2. And then feeding, carbon's passed from organism to organism. So you've got several marks there. See if your answer that you put down has any of those, and if not, just correct your answer as you can. Once we've done that, we'll go on to our final set of questions. So, the last set of questions for this lesson are the knowledge and application questions. So, pause the video, look over your notes, look over any extra information you've got and see if you can answer them. Then we'll unpause the video and we will go through them to finish. Right, unpause the video and we will go through these to finish. So, name the process by which evaporated water forms droplets. You should see that's condensation. Name the process by which plants take in water through roots and evaporate it through their leaves. Movement of water through plants is transpiration. Name the process by which rain falls from clouds. Forms precipitation. Give the general name for waste materials and decaying materials that contain carbon. Feeders of these are called detritus feeders. Name the process by plants, animals and decomposers that return CO2 into the atmosphere. What process gives CO2 off as waste? Respiration. Name the process that removes CO2 from the atmosphere. What process needs CO2? Photosynthesis. Bacteria and fungi are our 2 decomposers. And describe how combustion of fossil fuels has affected atmospheric CO2. It's increased because we've released more captured carbon. Now, these 2 questions draw the water cycle from memory and draw a carbon cycle from memory. You don't need to see it here because what you need to look at is look at your lesson diagrams. Can you produce those from memory? The diagrams that we've annotated and gone over in this lesson. If you can't, spend some time practicing. Can you draw them? Can you label them and keep labeling them from memory? That's your next task if you can't get all the points down. And the final question, describe how you could prove that carbon dioxide is produced by organisms such as bacteria and fungi during decomposition. How do you test for carbon dioxide? It's gas. So put the gas produced during decomposition If you're going to test for carbon dioxide, you put it through lime water. And if you put it through lime water, what would you expect as a positive result? To go cloudy. Going cloudy is your positive result. Good, right, so you've gone through cycling of materials for lesson 6 of your ecology unit. Well done.